Consider the set of natural numbers, which are just positive integers, positive whole numbers, 1, 2, 3, 4, 5, and so forth and so on. And the set of integers, which contains every positive integer, every positive whole number, every negative whole number, and 0. So the question is, which of these are larger? I mean, you could argue that, well, I see that the set of integers has every natural number in it and more. It also has negative numbers and it also has a 0 in it. So maybe it's larger? Well, you could argue that, but we will see that there exists a bijection between these two sets. And if so, it would mean that they have the same cardinality. We use the term cardinality to describe the size of sets. And we use this notation, two vertical lines next to the variable representing the set, to mean the cardinality of the set. And the set of natural numbers is represented with an n with a vertical line crossed through it. The set of integers is expressed with a slashed line next within the z, right? So how do we form this bijection? Simply put, we're going to associate every even number with negative integers and every odd number with positive integers. How so? Well, I'm going to use 1 to count 0. Then I use 2 to count -1. Then I use 3 to count 1. Then I use 4 to count -2. Then I use 5 to count 2. And I can keep doing this forever, you see. I can keep doing this forever, and I'm just going back and forth along the number line from 1 to 2 to 3 to 4 to 5. So in essence, if you wanted to look at a formula, it is as if n is an even number, then this is what I'm doing. I'm taking minus n divided by 2. That's the number that I'm choosing. In this case, the number 2, you half it, and you multiply it with a -1, and you get this number, -1. That's the number. And if n is odd, what am I really doing? I'm associating the odd number with this number, and -1 divided by 2. So for example, 3 over here, 3 was associated with the number 3 minus 1 by 2, which is 1 right here. Although it's not important that we are able to write an explicit formula. It is only important for now to understand that this rule of association is going to bijectively pair. It's going to create pairs between each and every natural number and each and every integer. And how am I so sure of this? Well, if I keep continuing in this process, left and right across the number line, indefinitely, if I just keep going forever, I would have enlisted every single natural number, some on the left, some on the right, yeah. And at the same time, I would have also enlisted every single integer, every single positive integer and every single negative integer. None of the numbers are getting missed out because they're appearing up in one of the pairs. Either they're in this pair, n and n by minus n by 2, or they're in this pair, n minus 1 by 2 and n, right? So the numbers appear up on either of these pairs, on either of the sides of the number line. It'll appear up on one of these sides. So in this manner, I can essentially count every single integer using every single natural number. So in a sense, they have the same size. So now let's move towards something a bit more interesting and closer to the topic that we really want to tackle.